In the previous video of power factor series, we have seen the different ways of improving power factor, out of which capacitor banks is the most commonly used way for this purpose. Now, it is important to understand where the capacitors are to be installed. So if you want to get the details, you need to watch the video. In theory, capacitor can be installed anywhere, but we must evaluate the relevant practical and economic feasibility. According to the location of capacitor, these are the types of power factor correction. Number 1, distributed power factor correction. Number 2, group power factor correction. Number 3, centralized power factor correction. Number 4, combined power factor correction. And number 5, automatic power factor correction. But before moving on in this video, I will recommend you guys to check out the description of this video, as I have mentioned some of the video that you should watch. So we'll get started with the distributed power factor correction. In this type of power factor correction, capacitor banks are directly connected to the terminal of the load which demands reactive power. This type of installation is very economical and simple. Capacitor bank and the load can use the same protective device against overcurrent as shown in the figure, and can be connected and disconnected simultaneously. This type of power factor correction advisable for the large loads which remains connected to the system for a long time. This type of correction is generally used for induction motors and fluorescent lamps. In case of direct connection, as shown in figure 1 and 2, there is a risk that motor keeps running even after the disconnection from the supply because of the residual kinetic energy, and it will self-excite with the reactive energy drawn from the capacitor bank and may turn into a synchronous generator. And hence, to avoid this, it is strongly recommended to use a separate switching device for capacitor bank as shown in figure 3. When using the connection shown in figure 3, capacitor bank is switched on after the motor is switched on, and it is turned off before the motor is turned off, which avoids the running of motor after it is turned off. Group power factor correction. This method is generally used for the loads which have similar functioning. A common capacitor bank is provided to improve the power factor as shown in figure. So for example, if you have 3 similar induction motors which is being used for a same reason, you can use a common capacitor bank for power factor correction. This method is also economical but recommended only for small loads. Centralized power factor correction. In a system, not all loads are connected for all day. There are some loads which are connected for a very short time. In such cases, use of distributed power factor correction is not a good choice. In such cases, centralized power factor correction is preferred, in which capacitor banks are located at the origin or at the center of the system. This allows a remarkable reduction in the total power of the installed capacitors. The capacitor banks must be installed with a switching device, as keeping capacitor bank connected permanently to the system is not a good choice. Combined power factor correction. As the name suggests, it is the combination of two different methods, that is distributed power factor correction and centralized power factor correction. In this method, distributed power factor correction is used for the large load which runs continuously, and for the power factor of small equipments are corrected by centralized power factor correction. Automatic power factor correction. In most of the system, there is not a constant absorption of reactive power because of the working cycle of the equipment. In such installations, there are system for automatic power factor correction which allows the switching of different capacitor banks when needed. This type of automatic power factor control panels, or APFC panels in short, consist of sensors for detecting current and voltage, switching and protecting devices, an intelligent system which compares the required power factor and the current power factor, and of course the capacitor banks. These types of panels are widely used. So that's all about the types of power factor correction. Apart from this, capacitor banks must be provided with switching and protective devices. Also, discharge facility shall be provided for capacitors. Nowadays, most of the capacitor comes with inbuilt discharge resistor.